Good evening to all of you. Myself, M. Ramarao, Secretary IGS Guntur Chapter. This is the 48th webinar of IGS Guntur Chapter, organized by IGS Student Chapter, RVR and JC College of Engineering Guntur. IGS Guntur Chapter established in 2003, organized number of seminars workshops, significant being IGC 2009 National Conference, held at RVR and JC College of Engineering Guntur. I am thankful to Mr. Rajesh Kumar Shekhawat, Senior Professor Projects, Indian Railway Institute of Civil Engineering, Pune, to deliver this webinar lecture, Design and Construction of Railway Formations. Before introducing the speaker, few announcements to participants. I request all the participants, please stop your video. And we are going to chat with the host only during the lecture, that is myself. Please chat audio and video issues only. Please do not share your information, questions during the lecture. After completion of the lecture, I will share Google Form link, and its purpose is sharing content of the PDF of this lecture and your feedback. Question answer session to chat at the end of the lecture. Our next webinar tomorrow at 11 a.m. by Professor Vishwas A. Sawant, Department of Civil Engineering, IIT Roorkee. And the title of the lecture is Oil-Soil Interaction Studies, subjected to lateral loads. Now I request Mr. TVS Krishna, Associate Professor and Advisor to IGS Student Chapter, to introduce this speaker.
Hello, good evening.
Good evening.
Sir, okay. I feel privileged and delighted in introducing Sri Rajesh Kumar Shekhawat, Senior Professor, Indian Railway Institute of Civil Engineering, Pune. He obtained his BE Honours in Civil Engineering from MBM Engineering College, Jodhpur.
Sorry, sir.
Hello.
Maruti Krishna, sorry, it became unmute and we can start once again. Sorry.
Okay. I am delighted in introducing Sri Rajesh Kumar Shekhawat, Senior Professor, Indian Railway Institute of Civil Engineering, Pune. He obtained his BE Honours in Civil Engineering from MBM Engineering College, Jodhpur, and ME in Geotechnical Engineering from University of Roorkee, now IIT Roorkee. His professional experience, he belongs to Indian Railway Service of Engineers, IRSC 1992 batch. As Assistant Engineer, Divisional Engineer, and Senior Divisional Engineer in various divisions of Southern and Southwestern Railway, he dealt with maintenance, construction, and inspection of track, bridges, and other structures. As Deputy Chief Engineer in Southern and Southeastern Railway, he dealt with design, monitoring, and rehabilitation of bridges. Worked as railway track expert on deputation to Government of Malaysia. Worked as director in Ministry of Railway and Ministry of Defense. Worked as director, geotechnical engineer in research design and standards organization of Indian Railway at Lucknow. He is a fellow in a number of bodies and societies, a life fellow of Institution of Permanent Way Engineers India, life member of Indian Institute of Bridge Engineers, life member of Indian Society of Rock Mechanics and Tunneling Technology, member of Institution of Permanent Way Engineers UK. His Nobel achievements, to mention a few, received Chancellor's Gold Medal for having secured maximum marks in all postgraduate courses of University of Roorkee, as IRSC probationer, awarded RK Jain Rolling Shield for being judged as overall best probationer of the batch, and received IRCON Gold Medal for overall best academic performance in the batch, as he co-authored of a paper titled as Stability Analysis of Slopes with Non-Circular Slip Surface and Non-Vertical Slices, published in Indian Geotechnical Journal, received IGS HECO Prize for Best Paper published in Rock Mechanics Stream. He was engineer in charge of the work reconstruction of major bridges number 924 in Shoranur, Mangalore section of Southern Railway, which received Indian Institute of Bridge Engineers Most Innovative Construction Award. in 2002-2003 for completing the work in short period of 42 days in year 2001. Has been awarded twice with K.C. Sood Memorial Award for co-authoring and presenting best technical papers in the Institution of Permanent Way Engineers National Technical Seminars held in year 2016 and 2019. Has been trained at International Center for Leadership in Finance, Kuala Lumpur, INSEAD Business School, Singapore, National Academy of Administration, Paris. Has authored 2 books on railway tunnels and geotechnical testing for earthwork in railway projects published by Indian Railway Institute of Civil Engineers, Pune. We are happy to have you here, sir, and you can proceed with your presentation. Thank you very much.
Thank you, sir. First of all, I will like to thank Dr. Ramarao and his team for having given me this opportunity for interacting with all of you on the subject of design and construction of railway formations. I'll be basically sharing with you what philosophy we follow and what are the essence of our standards which we follow in Indian Railways for design as well as construction aspects of formations. So to say brief about this, Research Design and Standards Organization, what we call as RDSO, which is headquartered at Lucknow, and I was privileged to having worked as Director Geotechnical Engineering there, is the key technical organization for Indian Railways research and standardization related matters. And they publish various standards, various codes, various guidelines, and various manuals. And our current standards or specification for design as well as construction of the formation, I can tell you they are at par with the standards followed in advanced railway systems. Regarding state of art, we are at par with whatever railway system of the world we can talk about. And the current specification, which is being used generally for most of the places, it caters to heavy haul. And normally in railways, the haulage is normally spoken in terms of axle loads. So we are having our specifications up to 32.5 ton axle load. And most commonly used now are 25 ton axle loads and 32.5 ton axle load. For normal railway works, all embankments are being constructed for 25 ton axle load. And for you must be hearing there is dedicated freight corridors. 2 dedicated freight corridors are under construction between Bombay to Delhi near Dadri, and then on east to west from Dankuni in near Calcutta to Jalandhar, this side. So there the axle load being followed is 32.5 ton axle load. And presently we cater up to 160 kmph speed because our presently passenger trains maximum speed is 160. And there was a proposal, and not proposal, in fact the progress work is in progress, what we call as bullet train or high speed between Ahmedabad and Mumbai, where the design speed is 320 kmph. For this also the specifications were under finalized. But later on, government as a policy matter decided that this track will not be on conventional formation because of various issues related with acquisition of land and maintaining track without fencing and all those things. So now it is being constructed on viaducts. It will be on the viaducts, and therefore these specifications were not finalized. But whenever it is needed, they will again get finalized. And to tell you about current standards, just a basic idea about how they were, sort of finalized or based on what they were based on. They are mostly based on standards and practices of UIC. UIC is a French name. Its English translation is International Union of Railways. This is the world body of railways research and standardization. So our specifications are primarily based on the concept followed in UIC. There are 2-3 concepts world over which are followed for embankment design. Most popular is UIC, which most of the European railways and most of the heavy haul and high-speed railways they follow in the world over. There is another concept which is known as AREMA concept, American Railways Association. Maintenance Association. That is a bit different from this. So we basically follow the UIC concept. And for doing this, basically what is done in UIC concept is something like this. I will just like to sketch with you. If we see the cross section of railway formation, the load through axles or wheels, it comes to rails. These are the rails. From rail, it goes to sleeper. From sleeper, below sleeper, there is ballast. So it gets distributed to ballast. And from ballast, as a uniformly distributed load, this goes to what is the top portion of formation is known as blanket. We'll see this in detail. And from blanket, it goes further to further layers. So normally the approach which is generally followed is that pressure intensity here should be less than or equal to 3 kg per centimeter square, and here it should be less than or equal to 1 kg per centimeter square. This is, I'm talking about repetitive dynamic load. So this is general concept which UIC follows. This is the basic concept. And so that's why I said that we are following the concept of UIC. And then for achieving this in Indian Railway standard, because we cannot ask users to do this analysis, every user at field cannot do finite element analysis or modeling. So some ready-made, based on this, we have done some analysis, and then we have specified sort of directly implementable parameters in the field as we will go along. So for doing this, FEM modeling and studies were done, wherein IIT Kanpur and IIT Delhi were involved. All the components of track and embankment, they were modeled, and some field studies were also done. And in addition to that, we have also gelled in the more than 150 or 150 years of experience of Indian Railway in construction and maintenance and strengthening of formations. And based on these three things, our specifications have been finalized, and in fact, it is a continuous process. Even last year and this year, we have issued some corrections, some additions, and RDSO keeps on doing it. There are people in the field also, they are also involved. There are committees. In fact, I am also a member of the committee which looks after this revision of codes and all, which did recent revisions. So this is in a nutshell how we finalize our specifications. Now we will go further. And some recent inclusions in the standard or specification, or some of the concept which we have introduced recently means I can say last 2-3 years. I will just briefly tell you before going into detail. One is world over, for design of flexible pavement, railway embankment is also nothing but a flexible pavement. The concept of EV2 is the state-of-art parameter. EV2 is a deformation or strain modulus of the embankment. V means it is variable load. So under cyclic plate load test, when you measure the strain modulus, and 2 is for second cycle. So for second cycle of plate load test, that is the strain modulus which you measure is EV2. So we have introduced EV2 as an acceptance parameter for the finished layer in earthwork. We will see later what are the values and all. This is a very, very recent addition. Last year, July only we did it. Then we have also introduced the concept of filter criteria. As we all know, that whenever two differently graded layer, they join at each other, for one layer not to intrude into another layer, especially the fine grained material of one layer should not go and spoil the coarse grained material or their pores of coarse grained material. There is a filter criteria. World over, many filter criteria are used. First one was given in Tarjagi somewhere in 1960s. So we have introduced a filter criteria also wherever two different layers are meeting. We'll see this. Then, even though in India, we understand in highways and even in airport authority, people have been using nuclear gauges for checking quality of compaction or compaction level, but there is no Indian code, or there was no Indian method. Now, in fact, we have published our railway test procedure for using nuclear gauges for checking quality of compaction. It is mostly based on ASTM and British code, but based on our Indian condition, few things we have tempered them, and this also has been issued. Then we have also issued, of course, for trial applications, design and guidelines for design and construction of RE structures for railway embankment. We have been doing a lot of reinforced structure for highways like ROBs and all, which we do, even railway does it. For our railway structure, there was no guideline. So last 3-4 years back, we have issued it. Of course, it is for trial application and it is under revision now. Then these are few of the specifications which have been framed recently, or wherever I put star, they are under consideration, likely to be finalized shortly. Like we issued specification for non-woven geotextile for use as a separator or drainage layer in railway embankments. We have also issued a specification for using geogrid as a basal reinforcement or stabilization layer in embankment. We issued specification for geocomposite drainage element behind retaining wall or abutments. Then geocomposite layer to be used as a basal layer at the bottom of the embankment or the base of the embankment. Then, you know, we have a lot of jute geotextile products, especially in eastern part, and National Jute Board and this there is an agency, IJRA, Indian Jute Industry Research Association. They are doing a lot of work. In consultation with them, we have published our own railway standard for using jute geotextile in railway embankments wherever possible. Then this is under finalization, will be issued shortly. Use of geocell mattress as a basal reinforcement at the bottom of the embankment, and then use of prefabricated vertical drains for ground improvement in case of soft soil or marine clays like thing. Of course, this is being used in railway extensively, but so far there was no, it was being approved on case-to-case basis. Now a uniform specifications is under issue by RDSO. So this is just a brief background about and use of slope compactors. In fact, in our new specification which we are issuing, we are specifically making it mandatory to use slope compactor in addition to normal compaction of the embankment, because I have seen the banks in other countries of the world, also in advanced country, in this country, as I told you, everything is at state of art. Only problem where we were little bit lacking was erosion control on the slope. So one is to give as much compaction on the slope as possible, and then slope protection, which I will just briefly talk to you. So with this background, now I will go to what actually are the provisions and a brief about our various stipulations regarding design and construction of railway formation. So before that, again, I will show the same sketch in a different way and explain various terms, because these terms sometimes are used differently by different codes and different countries. So when we talk about formation, actually we start from here below the sleeper. The things about this we normally consider as part of track. So first thing is ballast, and the thickness of ballast below sleeper is known as ballast cushion. Then after that, the top portion of embankment, this portion is known as blanket. Sometimes there may be no need of providing blanket also if your layer below that is good. So if it is provided, it is blanket. Many times a term sub-ballast is also used for blanket. But technically speaking, both are not same, because sub-ballast is always part of ballast and it will extend only up to this. If it is sub-ballast, its section will be like this. If it is sub-ballast, then its cross section will be like this. And from here, my embankment will start. Whereas blanket is part of formation, and therefore it extends to the full width of formation. So technically speaking, blanket and sub-ballast are not same, but as I told you, many places they are used interchangeably. So this is blanket. Below blanket, the man-made filled-up layer is known, we call it subgrade. This term we will be using, and many times we also call it embankment fill, subgrade or embankment fill. And many times subgrade also is divided into two layers, upper part of subgrade and lower part of subgrade. We'll see it. And the existing ground, this is existing ground level. The natural ground below that is called subsoil. So the terminologies which we will be using very frequently in coming slides is blanket, subgrade or embankment fill, and subsoil. Okay, so now what are the design and construction aspects in embankment? With the same sketch which I have just explained to you, I will show on that. First part is top width of the formation, this width. What is shown here, from here to here, this is top width of the formation. First design parameter. Second is height of bank or embankment above ground level. So we are talking about this. This is ground level, this is top of bank. So this is height of embankment above ground level. Then next is side slope of embankment. So this is side slope of embankment. We are talking about this. So this one. And it is rather than in degrees or so, normally the practice is to express in terms of 1 vertical to how many horizontal, 1 vertical to 2 horizontal, 1 vertical to 3 horizontal, 4 horizontal. So 1 vertical to n horizontal. That is how we express it. Then next parameter design aspect is cross slope of the embankment. You know, top of the embankment is not flat. It is falling from the middle. It falls on both the sides. So this slope is known as cross slope. So when we are talking about cross slope, we are talking about this cross slope of the embankment. And this is also this slope. And this is also expressed as one horizontal is to one vertical in how many horizontal. Next part is fill material. So there are two types of fill material, blanket and embankment fill or subgrade. So what are their thicknesses and what should be their specification? That is next aspect. Then what sort of erosion control measures? And erosion control, when we are talking, it is about erosion control on slopes. And last thing is actual execution of work, laying the earth in layers. So compaction, thicknesses, and so this are 7 aspects of design as well as construction of the embankment.
Hello, sir.
Hello, am I audible? Hello?
Yes, sir.
There was a power failure. There was a power failure here,
Okay.
so there was network failure.
Okay. Okay.
So, okay. You are able to see my screen and hear me now?
Yes, sir.
Okay, thank you. Now we will go to all these 7 aspects briefly one by one. First is about formation width. Now, formation width, this is the sketch. I will just explain to you. This is when we are talking about embankment and there is a single line, there is single track. This is when embankment double line, there are 2 tracks, one here and one. Yes, please.
Your screen, your PPT is not showing.
Is it not visible?
Yes, sir. Screen is not visible.
Well, I will just again try to share it. Now,
Now it is visible, sir.
okay, thank you. Thank you. So we'll start where we have when we talk about formation width. Let me just show with sketch. This is one thing where it is embankment and it is single line. You can see there is only one track and it is in embankment. Second can be there are 2 lines, 1 line, 2 line and embankment. So this is double line, what we call in embankment. Third can be it is single track, but it is in cutting. And fourth combination is double track and it can be in cutting. So these 4 are most common combinations. And for other combinations, of course, we can extend same thing. So for these combinations, the widths are specified like this. Of course, we are talking about broad gauge. I'm not talking about meter gauge and all because there are no more new constructions. So previously width used to be different, but recently we have made them same for embankment as well as cutting. That is number 1 in year 2015 rather. For single line in embankment or cutting, the width required is 7.85 meter. This is taking into consideration the width of sleeper from its strength point of view, required ballast cushion, ballast side slope, then some space on the side, what we call a cess for maintenance to walk and work and all. With all those considerations, for single line, this width is 7.85 meter, and for double line, it is 13.16 meter. And it is same now in embankment as well as in cutting. In embankment, of course, we measure it from this end of embankment to this end of embankment, whereas in the cutting, we measure up to here only. And after this, there are some side drains in cuttings and bumps and all, etc. So that's only difference in measurement. Otherwise, as far as the width of formation is there, it is same. First part. Second part was height of embankment, and the stipulation is the height of embankment should not be less than 1 meter above ground level or HFL, whichever is higher. And reason for giving this is it gives proper drainage, because if embankment is just at the ground level, any water stagnant in the ground will have tendency to come and stagnate on track and create problems. So just to have drainage, that is first thing. And second thing, it discourages is trespassing. It may not prevent trespassing, but in heavily city or town areas, people normally, if bank height is there, they are discouraged from trespassing it. So that's second reason. So this is second parameter about minimum height of embankment. Then coming to side slope of embankment. Now the side slope of embankment is decided based on slope stability analysis. A slope stability analysis is done giving the properties of all the layers, subsoil, including subgrade, subsoil, subgrade, and blanket, their properties, their geotechnical engineering properties, and slope is analyzed. And the method prescribed is Bishop's simplify method. We at right now, because this method, number one, it gives results on little bit on conservative side only, and it can be easily done even manually also, not so easy, but still as compared to other methods. And in Bishop methods also, for taking into account the pore water pressure effect, the use of coefficient RU, the pore pressure coefficient, has been defined. RU, as we know, it is pore pressure divided by weight of soil at that place, U by gamma H. This is RU value. So this method is prescribed. And for existing bank, if you are analyzing stability, then we can measure pore water pressure by using any instrument and calculate RU. For new bank, actual measurement is not possible. So there are two solutions. Number one, we do the modeling, hydraulic modeling, like many software now. SlopeW has got interface in SeepW. From SeepW, you get this value RU. Or design RU values are prescribed. We can use directly those design values from our codes. And it says, our code says that normally or usually up to height of 6 meter, slope stability analysis is normally not required. You just follow. Oh, again, there is a, am I audible? Because again, there was a power fluctuation. I think power has come back now. Hello?
Audible, sir.
Okay, right. Thank you. So it says up to height of 6 meter, if we give 2 horizontal to 1 vertical slope, that is sufficient, and we need not do stability analysis for every slope. But this is only usually. In some cases, we may have to do slope stability analysis for less than 6 meters also. And those cases are where it is soft, compressible, or marshy type of subsoil, like coastal areas and river delta areas and all, what we call marine clay or soft soil, as we normally say. In those areas, because even smaller banks, we have even experience in coastal areas. I have worked for a long time in coastal areas. Even banks of 3 meter and 4 meter heights, they have fit. So even with slopes steeper than, flatter than 2 horizontal to 1 vertical. So there we must do slope stability analysis for any height of bank. And second thing is, even if this is for subsoil is weak, and even if subgrade also is having very low value of, subgrade is fill material, if it is having low value of C dash, and low value is defined by C dash by gamma range of 0.01, or C dash is effective cohesion value, gamma is its in situ density, and H is height of embankment. So in these two cases, we do the slope stability analysis for smaller height slopes also. And in our slope stability analysis, we don't take live load into consideration. And reason for that is that this effect of this load, this strain load effect, which is coming here, it dies down in top 1 to 1.5 meter of formation. In fact, even we have checked this by modeling also and physically also by putting pressure cells and all. The live load effect does not go below top 1 to 1.5 meter of the formation. And if you want to take live load into consideration, analysis becomes a bit complicated and difficult, and therefore we don't take live load into consideration. That is the reason. But this becomes an issue in case of smaller height embankment, because if my embankment height is less, embankment is 3 meter, then 1.5 meter of that height is influenced by live load, and that becomes significant. So there, how we take into account, I will show in next sentence. And the minimum stipulated values of factor of safety after doing slope stability analysis by Bishop simplified method is for short-term end of construction. Just at the end of construction, only for short-term use before putting any other thing there, we can go up to 1.2. Otherwise, preferably is 1.4. For long-term stability, 1.4. And for smaller height embankment, as I was telling you, the effect of live load is indirectly accounted for by prescribing higher factor of safety 1.6. So for embankments of height up to 4 meter, the prescribed factor of safety has been kept as 1.6 because we are not taking into account live load effect. And for these embankments, live load cannot be neglected. That's the logic. And after doing all these analysis and all, either you provide slope as per analysis, which is found to be safe, or minimum it should be 2 horizontal is to 1 vertical. In normal case, other than reinforced slope, normal slopes, they should not be steeper than 2 horizontal is to 1 vertical. The reason is, number one, our Indian railway system is still semi-mechanized. There is human beings who work, they climb on the embankment with some weight on their shoulders and all. So climbing on that becomes difficult. And second is, in case of rain, the velocity of rainwater becomes high and it causes more erosion to the bank. Based on these two considerations, this is, but there are steeper slopes, and this also, there we have to take special measures, or we have to make reinforced slope or protected slopes. Then coming to the fourth part, that is cross slope. So this is what cross slope is there. In case of single line, it starts from the center of track. This is new single line when we are constructing, and it falls on both sides. And in case of double line, it starts from center of bank and then falls on both sides, and its value is 1 in 30. This is the design value of cross slope, and it is given for drainage because you don't want your formation to remain in contact with water for a long time. Drainage is the best maintenance practice in railway embankment, or for that matter, any embankment. So we want to drain the water away from the formation as early as possible. And that's so this is first line of defense against that. 1 in 30 cross slope, and 1 in 2 is the tolerance provided. So after execution, when we measure, it should come within the value 1 in 28 to 1 in 32. Now we come to the fifth part, that is fill material. What should be their thicknesses and what are their specifications? Now, first of all, our attempt, and that for that matter anywhere world over, any geotechnical engineer always try to use locally available earth to the extent possible, because otherwise it increases cost of material, which increases cost of project, the timelines for project, and it causes a lot of environmental pollution in terms of diesel, which is burnt for running all those dumpers and vehicles and all. So generally we say any type of material can be used except unsuitable material. That is world over, even UIC and all, that is the practice, that only unsuitable material list is defined. Other than that, everything else is suitable. So unsuitable materials are, first, any type of organic material. Organic material, it can be organic clay or organic silt, is not allowed to be used. Peat, it is another organic material, not allowed to be used. Chokes and dispersive soils, they are not allowed to be used in formation. Then poorly graded gravel and sand, and here poor gradation is defined, number one, with CU value with coefficient of uniformity less than 2, and then we have specified some limiting gradation curve. They are like this. These are the charts. So this is gradation chart. This is grain sized in log scale and percentage finer, and these are between these two boundaries. These are boundaries for most liquefiable soil. So these soils should not be used. And then another second choice is this next band. They are potentially liquefiable, so must be avoided, but if it is unavoidable, then we can use it, but this should not be used. So this is how it is defined, the poorly graded, mainly from liquefaction point of view, that during dynamic condition, embankment should not go to liquefaction stage where shear strength becomes 0. Then CH and MH type of soil classification, which is clay and silts of high plasticity, they should not be used in top 3 meter. Because as I told you, in top layer only stresses are more, their live load effect is also there. And second thing is the effect of water, the seasonal variation of water also is in top layers only. Problem with this type of soils is, even Indian Railway, where the embankments have been constructed with such soils on top, we are having a lot of problem. As on date, there is around 5,000-6,000 kilometer length, which we are trying to rehabilitate. There, if you put this, when water comes in contact with them, they are expansive type of material. They will expand and they will disturb the track. They will weaken and bearing capacity will reduce. And during dry season, again, it will shrink and cause track disturbance. Cracks will be formed in the embankment. It becomes unstable formations. That's the reason. And even then also, if it becomes inevitable, or it is economical consideration based on some places, maybe for 100 kilometer length or something, you don't have suitable material, then what you will do? So that's why term used is generally avoided. In that case, we can use weaker soil, of course, but then case by case remedial measures or treatment has to be decided in consultation with RDSO or maybe some good consultant, and then use where it becomes unavoidable to use such type of thing, then case by case some method has to be decided. So this was about, in general, about type of fill material. And then there are some 2-3 terms which you will be using. So I will just briefly explain them before telling the specification further. We use a term which is called, it is used world over rather, it is known as single layer and 2-layer system of construction, or single layer and double layer system of construction. What exactly it is? It is this. In single layer, the blanket layer, top layer of, actually blanket is the most costliest material. If we see that, this basic from economic point of view. As we go down and down, see, most costliest material is ballast. Next is blanket. Next is my subgrade. And of course, subsoil is just available there freely. So I try to minimize the thickness of blanket to the extent possible from economy in construction point of view. So in single layer system, that is our conventional system, there will be blanket layer, and below blanket layer, we will have subgrade layer, the sketch which I have shown you. But in 2-layer system, the blanket layer is divided into 2 parts. Top portion is known as blanket layer, and second part below that is known as prepared subgrade layer. And then below that, our normal subgrade starts. Prepared subgrade is a material which is inferior than blanket, but it is better than subgrade. And why it is so, I will just briefly explain to you. Let us say in this case, now blanket layer thickness, sometimes it goes up to 60-70 70 centimeter also. If we take the stresses here, on top of blanket, let us say this P1 is the stress. And there is a substantial reduction in stresses through the blanket. So when we go with blanket, at the bottom of blanket, this stress may be P2. Now P2 is quite substantially less than P1. So a significant amount of blanket material in bottom portion is being underutilized because it is subjected to only this stress P2 and little bit more, whereas it is fit for P1. And that's why this concept of prepared subgrade came. Here what happens is, this is your stress distribution like this. So this material, bottom material, you can have little bit inferior material, what we call prepared subgrade, because it is subjected to lesser stress as compared to blanket. So this we call it single layer and 2-layer. This layer is with respect to blanket only. That's why if blanket is in 1 layer, single layer. If blanket is divided into 2 layers, blanket and prepared subgrade, we call it double layer. Most of the places this system is economical, except few places where blanket material is available at very lesser cost. There are few parts in India where either due to lot of quarries being there, stone quarries, or local material is so good that blanket cost is less. But those parts are hardly, we have done a survey pan India from RDSO, and we found only 5 to 10% part of the country are where blanket will be cheaper and it will be lesser. So therefore, mostly this is followed, but at some places this concept may also be followed. It has to be decided on which concept will be cost economical. Then there is another terminology which basically came from UIC and which we are also using. This is different than engineering classification. We call it soil quality classification. Since soil quality is the consideration, we call it SQ classification. And all our soils or fill materials are divided into 3 categories: SQ1, SQ2, and SQ3. And this bifurcation is basically based on fines content. Fines passing 75 micron C. So if my fines content is more than 50%, then we call it SQ1 soil, most fine graded soil. And this generally, these engineering classifications, they will fall in this category. But this is governing. If there is a contradiction between this and this para is only recommendatory, this is governing. So mostly these soils, engineering soil classifications, will fall in SQ1 category. Second type of soil, which is better than SQ1, is known as SQ2. Their fines content is 12 to 50%, and these soils will fall in this category. And best type of soil is SQ3, most coarse grained, cohesive soil, non-cohesive soil. And their fines content is less than 12%, and this sort of soils normally fall in this category. So this is another terminology. Why I am using this single layer, double layer is we'll be using this term when we go to further slides. And SQ1, SQ2, SQ3. SQ3 is best, SQ2 is in middle, SQ1 is most fine grained and least strength soil. Then this I already told you, EV2 value. EV2 is strain modulus. We have introduced, and it is a strain modulus taken from second step of cyclic plate load test or second cycle. There is no Indian code for this. This is the code which is followed by UIC. This is followed by European standard. This is German code DIN 181342012. This is a plate load test which is done on the surface. You don't dig in. And nowadays there are ready-made equipments available in India. Within 15-20 minutes, you can finish test. The microprocessor controls where directly results can be processed, they can be printed, you can away and take to your computer. They use 30 centimeter dia, round steel plate, 1 inch thick, for doing this plate load test. Then filter criteria, I have told you we have introduced the filter criteria, and here we use filter criteria between the blanket layer and the layer just below it. Because blanket is a costly material, and our experience has been there are many cases where the material below blanket over a period of maybe 5-10 years starts migrating upwards, and this blanket keeps on puncturing in the material below this, and after some time the blanket gets fouled by the fine grained material below it, and the whole function of blanket is hindered, and therefore this filter criteria is given. It is a standard thing in world over, wherever two dissimilar things join, even in dams and all, this is used very frequently. And the filter criteria which we follow is, there are many filter criteria world over. It consists of 3 parts. First part is the D15 size from gradation curve of blanket should be less than 5 times D85 of layer below it. So layer below it, in case of 2-layer or double layer system, will be prepared subgrade. Otherwise, single layer system, it will be subgrade. Second criteria is D15 of blanket should be 4 to 5 times more than D15 of layer below it. And third criteria is the D50 of blanket layer material should be less than 25 times D50 of the layer below this. All 3 should be satisfied simultaneously. Then filter criteria will be satisfied, and chances of upper layer getting vitiated by the lower layer of lower gradation will be avoided. Then there is a concept of field compaction trial. See, what happens is we do modified Proctor test, or in our railway we have specified modified Proctor test. We take the type of soil, in generally what we do, whichever we are going to use, and we do a lab test, modified Proctor test, wherein we measure the maximum dry density and optimum moisture content. But there are a lot of difference. It is lab and field conditions are not exactly same. Like effort, which make difference in the MDD which you are going to achieve in the field, and they are not accounted for, or they are not taken cognizance in the lab test. And therefore, there is a stage called field compaction trial. First, we do the lab test. Then, using that lab test data, we go to the field and do a field compaction trial, wherein what we do, whatever type of roller or its tonnage, that is compaction effort, we use same roller. We use same soil, which we have tested in lab and which we are going to use at the site. And then additional things which come here, which are not accounted for in the lab test, is how much layer thickness I am going to use in the field. Normally, we use around 250 to 350 or 400 mm layer thickness. So even then, if I use 250 and 400, my density achieved will be different. So there is a combination that how we do, there is a procedure. So we will decide what soil thickness layer I will use. And moisture content also can vary a little bit from MDD, plus minus 2%, 3%, this side, that side. Using these parameters, I do actual trials in the field, and I confirm that yes, whatever values I got in the lab, I will be able to achieve them in the field with these parameters. parameters. That is done in field compaction trial before starting the work. And the stipulation is that in field compaction trial, we should achieve minimum 98% of MDD, which we have achieved in the lab. Then this becomes my benchmark. For further works in the field, this value, the value achieved in field compaction trial becomes my benchmark and not the lab value. So it is sort of a validation and confirmation of lab result in trial before actual full-scale implementation in the field. That's next concept. Okay. Now, with these 2-3 concepts, now we will go to specification for blanket layer. What is the specification of blanket layer? This is the specification of blanket layer. CU must be more than 7 and CC must be within 1 and 3, because requirement is it has to be well graded. So this is from that point of view. It must have some fines between 3 to 10%. Why fines are required is, if fines are not there, then making a homogeneous mix at site is difficult. It is like kneading our, flour in our houses for making chapati or puri. If there are no fines, if it is very porous, you don't get a good kneaded flour. So that's why you require fines. And if there are no fines, another problem is there will be erosion during rain, a very, very coarse grained material blanket. And therefore you need some fines for binding. And that's why minimum 3% and maximum 10%, because more fines means your soil will become plastic and plastic deformation will be there, which is not desirable. Then blanket, getting naturally occurring material is very difficult. As I told you, we did study Pan India and we found only 5 to 10% parts in India you can get a naturally occurring material fit as a blanket. Balance places, you have to do some blending. So you will take some quarry dust or stone dust from crusher and add different grading either at the crusher or some natural material with the stone dust. So that material which you are using, manufactured material, is not in the grain form. See, natural material, sand or something, it will not get crushed to less than grain size. But a manufactured material can get crushed during the service life, and therefore its abrasion value is important. And therefore Los Angeles abrasion value is also specified. It should be less than 40%. Normal Los Angeles abrasion value test. Then its minimum CBR value for this material is specified at 25, and CBR should be checked at 100% of MDD. And size and gradation also has been specified. A envelope is given like this. So these are the two boundaries of envelope, and we must plot the gradation curve for blanket, and our gradation should fall more or less within this envelope. Little bit outside, okay, but more or less it should fall within this envelope. So this is gradation. Then filter criteria should be satisfied. We have seen what is filter criteria. And this minimum EV2 on top of compacted blanket layer is specified as 100 megapascal, wherever your formation is designed for 25 ton axial load, and 120 megapascal for 32.5 ton axial load. And the compaction level which we should achieve should be 100% of MDD achieved in field trial. So this is its specification. This is the table. I will just briefly explain about specification of prepared subgrade and subgrade layer. So this is, first we will see single layer system. In single layer system, below blanket, there will be only subgrade. Subgrade also we have divided into two parts, again from economy point of view, because lower layer can be weaker also, top layer has to be stronger. So what we call a subgrade top layer and subgrade bottom layer. And in double layer system, there will be prepared subgrade, below that subgrade top layer and subgrade bottom layer. So there all this soil type, what type of soil. Only thing is in top layer of subgrade, and SQ1 is normally not used. It should be used with dispensation from principal head of the department, only in exceptional cases. Otherwise, and prepared subgrade SQ1 is not allowed. Then these are the required CBR values. This should have more than 6, 3, 8, 5, 3. And if you use SQ1, then it can go up to 4. And here also, if you use SQ1 up to 4. And at what MDD level this CBR should be checked. Field compaction levels for various layer, 98%, 97, 98, 97, 90. As we go down, the general concept is as we go down in the embankment, even compaction level also can be a little bit less. Soil also can be a little bit inferior type because stresses will be less. And exposure to seasonal moisture content will be less. Then minimum EV2 value on top of this. EV2, we check only on the top of the layer. Let us say in subgrade, there may be 6 layers. So on every layer, we will not use the EV2, only on the 6th layer top we will use. So subgrade, prepared subgrade, and blanket, only 3 places it will be used. So this is value required if SQ1 is used. Otherwise, this is the value. This is on top of prepared subgrade, and this is on top of subgrade if SQ1 used otherwise. And only for prepared subgrade, there is a stipulation that it should not have plasticity index more than 12. Should not be having more plasticity. Okay, and this is a chart for thicknesses. So we have seen the specification of various layers, then thicknesses are specified. I will not go much into this detail. This is first for single layer system. And as I told you, you got two system, 25 ton axle load and 32.5 ton axle load. So we start from subgrade top layer. Subgrade top layer thickness is 1 meter in both the cases. So subgrade top layer, that layer must be of minimum 1 meter thick. And we can use SQ1 with, of course, dispensation from PHOD. That's why we can use any type of soil, SQ1, SQ2, SQ3. And depending on type of soil used, blanket layer thickness will be decided. Because if you use poorer layer, then blanket thickness has to be more. So that overall system has got same thickness. So for SQ1, it is 55 centimeter, SQ2, 40 centimeter, 30 centimeter. And this is for 32.5 ton axle. These hydrograms are there. We can refer them. I will not explain it. Similarly, when we go to two-layer system, here there will be blanket, then below that there will be prepared subgrade and subgrade level. So here also there are two charts, 25 ton axle load, 32.5 ton axle load. Here again we start from subgrade top layer. So subgrade top layer thickness here is half meter, 50 centimeter. There it was 1 meter. Then depending on what layer we have used here, SQ1 or SQ2, next what will be layers here, prepared subgrade thickness is there, and depending on what type of soil we have used here, blanket thicknesses are there. So these are charts for various blanket. This basically all this combination, it started from that finite element modeling, and then what is the characteristic strength for SQ1, SQ2, SQ3 type of soil, and from there how much stress will come, and this is a reverse calculation. A field person, as I told you, cannot do FEM analysis and modeling. So for him only thickness and specification have been specified, but basis is modeling and permissible stresses. Then there are some other 1 or 2, 3 stipulation which I will quickly cover. One is if we use subgrade or prepared subgrade of fine grained material. Fine grained can be SQ1 or SQ2, both are fine grained, because in both cases fines can go up to 50% or more than that. Again, the doubt is if fine grained material is used below blanket, then your material may foul your blanket. So in both these cases, this is double layer system. So in double layer system, this is my blanket, this is my prepared subgrade, and this is my subgrade. So here at the junction of prepared subgrade and blanket, I use a separator layer, again to prevent fouling of this ballast. And in single layer system, below blanket, this is my blanket, and below blanket is subgrade. So at this junction, I used a separator layer, and this separator layer is a non-woven geotextile separator layer with specification is separately given. When we use separator, then these two material filter criteria need not be satisfied because they are not even coming into contact with each other. If I am not using separator, then I have to satisfy filter criteria. That is simple logic. Okay, then this is about, now we have seen our material specification. Now field compaction. About compaction, as I've told you, we do lab test, then do field compaction trial, and then compaction level to be achieved for every level V2 I have told you, and compaction checks are done on completion of stipulated area of compacted layer. The plan area of any layer, once that much area, it is 500 square meter normally, and at critical location it is 250 or 300. Normally it is 500 square meter. Every 500 square meter of plan area, a compaction test is done, and any of these three methods can be used: sand replacement, core cutter. As we know, sand replacement can be used for any type of soil, and this is IS code. Core cutter can be used only for fine grained soil. In porous cutter, porous material, number one, your cutter edges, core cutter edges get deformed, and you cannot take full sample. It gets crumbled. But this is the code, and this is what I was telling. This use of nuclear moisture density gauges. They are very fast. They do the test in 3-4 minutes. They are very accurate. You can do multiple tests at same location. Here, once you make one pit and all, you cannot do another test there. You have to go a little bit on the side, and you can take the results in your computer. It's a very good thing. So for this also, we have issued a procedure, and it can be used for all type of soil. And EV2 check, in addition to degree of compaction, the EV2 check also is done on finished, top of finished subgrade layer, finished prepared subgrade layer, and blanket layer for every 1 kilometer length of formation. Every 1 kilometer, one EV2 test is done, and we must get the value of 100 or 120 megapascal, as I told you. Then next is erosion control of slope, the last part of construction or something. So for erosion control, most economical or preferred method is to grow locally available vegetation in the form of turfing. During rainy season, you grow vegetables, whatever locally growing grass or doob or whatever material, bring it in the form of sods and put it on the embankment. It grows. 70-80% of the cases, this is successful, most economical and preferred choice. Some places, either they are very dry or soil is very, very infertile, does not have any nutrients. And if there is a problem, then we have to try other method. But there is a grass which is known as vetiver grass. This grass is one such variety which is grown everywhere across the India. It has got different name in different. In fact, we have in our standards we have published a list of name also, that in Gujarati, Marathi, Telugu, Tamil, Punjabi, Rajasthani, UP, Bihar, Bengal, what name it is called. It is called with different names, but which is one such grass. In fact, this is recommended by ECAR, Indian Council of Agriculture Research. We say it grows in most of the conditions. So if locally available thing is not growing, then we try vetiver. This vetiver, you can see, this is human being, it can grow so much high. This is vetiver grass, and it is planted in the form of hedges, and you leave some space in between. After some time, it will cover. So this is how this vetiver can try. If that also does not succeed, due to maybe either due to type of soil or scanty or very excess rainfall around, then we have to go for some external measure by using geosynthetics to aid the growth of vegetation. It will absorb moisture for longer time. Maybe it will give extra nutrient also. And geosynthetics here on this slope, you will put this geosynthetic layer, and then you will try to grow vegetation in this. So geosynthetics in the order of cost and in the order of preference is this. Generally, we must use jute geotextile or coir because they are very, very cheap. They are local material, sort of Indian made material. And as I told you, we already issued specification for jute geotextile. Coir, which is National Coir Board, I think RDSO is in talk. So far, it has not happened. This LAP. Jute people are a bit more, they have done a lot of research, more than coir. Coir also they done, I'm not telling, but jute geotextile is a very well developed thing. And they are made from natural material. Quite with this problem will be solved. Even then also, if it is not solved, then further in the order of priority, we can use geomats. So we lay geomat here, nail it, and then put some soil cover here. In this soil, we can put some nutrients also, some good type of soil where vegetation can grow. Next thing, there are reinforced geomats also where boulders are there in the bank, and also that it does not get torn apart in tension. Then if geomat is also not working, then we can use geocell mattress, because here thickness will be only 1 to 2 inch of extra soil. In geocell, you can go 4 to 8 inch of extra thickness. So put geocell, and in this geocell, anchor it and then put good soil and grow the vegetation. And if that is also not succeeding, the final Brahmastra is hydroseeding. You can grow grass on any barren land, any waste or wherever, but it is very costly. And hydroseeding, as you all know, it comes in it is a patented product, everything which is content, it comes in a bag, you just mix with water and spray it, and within 10-15 days, your shoots you can see. In fact, we have tried in railways at 2-3 places. Recently, I remember we have tried in new line between Bangalore and Hassan in one of the things, where it was very, very barren and all boulders and all were there, nothing was growing. And within 8th or 9th day, this green shoots started coming. So this is slope protection, and last is subsoil. Now, whatever man-made parts we have all seen, this is last slide, existing soil, whether we should do something there also. Yes, if it is weak, we have to do it. So we call soil or classify as weak based on 3 criteria. These tests are done as part of soil exploration or geotechnical investigation. If EV2 value of soil is less than 20 megapascal, or undrained shear strength is less than 25 kilopascal, or corrected N value in standard penetration test is less than 5, then the subsoil or existing ground is classified as weak. And this is very, very common, as I told you, in all of our coastal areas, river delta areas, or along the rivers, and some other parts of India, where marine clays and all are worst problem, of course. So there, if your soil is weak or soft, then ground improvement is to be done. I'm not going into those details. There are various methods of ground improvement. If layer is shallow, then you remove bed layer and put good soil, or you can use prefabricated vertical drain, You can use stone columns, you can use geosynthetics, encapsulated stone column, all sort of things are there. Why ground improvement is required? Number one, if you don't improve the ground, let us say this is my existing ground and this ground is weak. If I construct embankment over this and start running my train, this ground will keep on getting consolidated for period up to 5 to 10 years. We can calculate. I developed a software also for developing consolidation time. Even for 10 to 15 meter thick layer, it goes up to 5, 6, 7, 8 years. For 8, 10 years, this ground will keep on settling, this bank will keep on settling, and my track will keep on getting disturbed, which is not allowed, because the tolerance is required at rail level in case of track is very, very high as compared to road. That is one thing. So we want to reduce the consolidation time and settlement. I want, before I start my trains or rather construct track, all my consolidation should have happened. I want to enhance the consolidation. Second problem is when we construct a bank here and if the soil is weak, then there are base failures. The whole embankment fails and there is a heave here. So I don't want that also. So to increase bearing capacity or shear strength of subsoil, which is least just after construction, because that time your pore water pressure is maximum. After that, it will go down. So because of these two reasons, we have to do ground improvement that is specified. And for that, we must use suitable techniques for ground improvement. That's what. Thank you. That is what I wanted to present. Now I will stop the presentation and I will take your questions in, I will see the chat window.
Sir, before going for the question and answer section, I will share the
please
feedback forms.
Please, please.
No, question and answer session.
Yeah, feedback link is there. Kindly see the feedback. Dr. Ramarao has said it. Now, if you have got any questions, kindly. Good presentation. Thank you. Thank you. Any other questions? Kindly feel free. Does mixing of soil acceptable for prepared subgrade layer? Yes, it is in fact acceptable for everything. What happens is mixing adds a cost element. So in blanket, it becomes almost inevitable. You have to do blending. Otherwise, you cannot you cannot get blanket specification. In prepared subgrade, it is not prohibited. Anybody can use mixing of soil, but normally people don't do it because it increases cost of material. And prepared subgrade thickness, generally the type of material is available, maybe with little bit extra lead, it is available as a naturally occurring material also. And another thing is, even if you want to reduce prepared subgrade thickness also, I could not cover it because less time. Let us say prepared subgrade thickness given is 50 centimeter. If you want to reduce because of material non-availability, then we have got a specification for geogrid. You minimum biaxial geogrid suitably designed. Design we have issued. You can use geogrid and reduce its thickness. So it is not prevented. That is one. Second thing is, okay, so good question. Limiting settlement for embankment. See, I will tell you. In Indian Railways, we have not specified the limiting settlement for embankments because of various reasons. And our speeds, as I told you, over there up to 160. The moment we go about this, like we were considering it for our bullet train and all, it was being specified, but it is done in UAE. In fact, I did a project. I was involved with a project in Malaysia. I was government advisor there. We had a limiting settlement. It is specified in two terms. One is 1 month after construction. That is, we normally take at end of construction. And second is taken as long term. So that is after 1 year and after 2 years. And for that, during construction of embankment, you embed MPBX, multiple point borehole extensometers. Take their leads out and take to a box, and then you keep on recording. So presently, we don't have any limiting settlements. But yes, I can tell you the moment we make we are almost ready. The moment we issue specification for more than 160, it will become essential. Next question is, how difficult is it to achieve 100% compaction for blanket? I got to see previously, people used to translate our lab test result directly into the field. And they used to say, sir, 98% nahi aata hai, 97% is not coming, 100% is not coming. To do away with that only, we have introduced this concept of field compaction trial. Now lab results, you verify them based on everything, same roller, same soil thickness, layer thickness, and you check that I'm going to achieve that density. And this 100% compaction for blanket is 100% with respect to what you achieved in field compaction trial, which is 90% of lab trial. Therefore, this 100% is achievable. In fact, this change we did in late 2018, and after that, now to whatever our people I'm interacting, they are comfortable with that. Previously, this used to be a problem. Second, next question is GeoGrid and GeoCell in pavement layers are becoming common in highways. It is encouraged to use GeoGrid or GeoCell. Yes, as I told you, in last 2 years itself, we have issued, I have shown you the list, around 7 specifications for use of geosynthetics. Separator layer, basal layer, geocomposite drain, reinforcement stabilizing layer for thickness, and GeoCell is under issue. GeoCell has not been issued, but others have been issued and not only encouraged, some places it is mandatory. We cannot construct the track without that. And another big issue on hand with us is rehabilitations of our existing weak formations. In fact, there are large length of formations in Indian Railway, which are, in fact, incidentally, this is IGS Guntur chapter, and that area has got maximum amount of your Bapatla, Chirala, this side come from Vijayawada when you go towards Vizag and all. There are notorious black cotton soil stretches where every rainy season speed restrictions have to be put. We have got around 6,000 kilometers of such stretch in Indian Railway, and in a large mission mode, we are trying to rehabilitate them. And there, use of GeoGrid and geotextile nano is inevitable. We just cannot do this without that. So not only encourage it, it is rather become essential for us. Tell me about pile foundation. Well, I am not covering pile foundation. I will not be able to tell. If you got any specific question, you can ask. Only thing which I can tell in terms of embankment on bridge approaches are one of the vulnerable locations. So there, because your approach stiffness is lesser and bridge deck stiffness is more, so you have to give it transition. There are various methods of giving transition. There we have to do, rather I must admit, substantial work. There, like in our Malaysian project we did it, there is a concept called piled embankment. You take hollow either concrete pipes or you take maybe cast iron pipes, you drive them into the ground and drive them at a varying spacing. That gives you the graded transition in the stiffness. But otherwise, pile, since we have not covered, so I will not like to go into detail. Then next is, sir, we are working in Paradip port, which is coastal near to sea. Can we use quarry dust instead of muram as we are not getting? You can use anything. In fact, if you see our last specification, which was issued in 2019, I am a member of specifications drafting committee. It says you can, it's in fact says that normally muram is, see, I will tell you, muram is a very, very colloquial term. There is no technical term called muram in geotechnical engineering. I worked in southern India and then I worked in Calcutta, where this area used to come under our jurisdiction. We call any red soil or any yellow soil is called a muram. Really speaking, muram is not a technical term, but it is a good quality red soil or yellow soil, which you find some places. So, but that is naturally occurring material. As I told you, most of the time it is not able to fulfill the blanket specification. Therefore, if you read our specification, current specification of July 2019, it starts with this, that normally it will be difficult for you to get a naturally occurring material. So you have to use manufactured material, which includes quarry dust. So yes, it is very much allowed. It must meet the final specification. In fact, that will be the default choice in 90% of cases in Indian Railway. I will say this. Are recyclable materials slags, waste, foundries, and no? Because I will tell you why. Slags and your foundry waste and all, their gradation is very, very high. So they cannot be used as a fill material. We tried them using as ballast from Bokaro steel plant. In fact, I was posted in Calcutta at that time, but there are problems in that. Number one, we don't get angular things. They comes in rounded shape and that does not give us the required track modulus. Second thing is they have got very, very high corrosive tendency, which corrodes our rails, which is costliest material. And therefore, for the time being, they are not being used. And in fact, in world over, I will tell you, because I was personally involved with this project and we did in RDS. So other than siding world over, nobody used this slag material for as part of embankment. And as far as fly ash is concerned, that also project we have done. In fact, we have not put in our specifications, but there is an unwritten rule, or maybe sometime it will be put, that any material which has got maximum dry density less than 16 kilonewton per cubic meter is susceptible to collapse behavior when it becomes wet. And in highways, it can be used because they make cored embankment, and on top there is an impervious layer of bitumen, whereas our embankment is exposed to rain. So that, and in fact, we did trials by taking fly ash from many places. There are three types of fly ash, if you know. One is fly ash, then pond ash, then bottom ash. All three of them, number one, don't meet this minimum dry density criteria, and all of them except bottom ash, their CBR value is less than 3, which is not allowed to be used in embankment. Bottom ash has got good CBR value around 10 to 15, but their dry density is very less. And second thing, if you check from any of this power plants, the amount of bottom ash produced is very, very small. So it can be used at many other places. That's why we are not encouraging that. Next question is from Mr. Kiran Kumar. It is in the presentation, it is mentioned that N is more than 5 for considering subsoil conditions. Since SPT variations will be high during seasonal change, how can it be justified? Whenever we are talking N value, it is to be taken in the worst situation. Worst situation is during rainy season. But there also I will tell you, see, it is like this. In fact, this also we did a study during our DFC, that even in worst of the soil, like here, Bharuch and this Surat and this area, there is a black cotton soil belt. Even in those belts also, the effect of moisture variation does not go more than 3 meters below. So maybe top 3 meters you may have different. There also we always prefer to do it in wet season. Below 3 meters, your effect of moisture will not be more. So your N values will be correct values. Next is, in future, India have uniform gauges. We already have uniform gauge. We are already on broad gauge, and whatever meter gauge and narrow gauge, other than for heritage, all have been mostly converted or being converted. So our gauge, as far as Indian Railway is concerned, is broad gauge. Metros are not under Indian Railways; they are under Ministry of Urban Development, and metros are following 2 gauges: standard gauge of 1453 mm and broad gauge as Indian Railway. Because of non-available, now of course plants have come up, but previously this rolling stock, the coaches were not available, so they had to go for standard gauge. In highway project, we have CBR 10% board railway. See, this 8% is only for a particular layer. This 8% is only for a particular layer. Above that layer, blanket layer is sitting, where we require minimum 25 years CBR. And this 8% we arrived based on this, that on top, below blanket layer or below prepared subgrade layer, my density, my stress density or my stress range, my stress value should not be more than 1 kg per square centimeter. And we are able to get it with 8 with normal correlation. And in any case, for finished product, EV2 is the final test. Let me tell you, CBR is a potential of material, how much strength you can get. But material may be good. I don't do compaction properly. I don't add moisture properly. I will not get. So CBR is a potential of the material, what strength it can get, whereas proof of the pudding is in eating, that is EV2 test. That's why we have specified both the test, CBR as well as EV2. And EV2 is 100 or 120 on top of compacted blanket, depending on what axle load design is there. My contact details, I will write it here just at the end of this. And if you want further, our Irisen website is there. In fact, we have got a lot of material. If you have got time, just 2 minutes I will take after this and I will show you. We have got a lot of material, and every day we are putting a lot of material there. Please feel free to make use of that resources. It is, even though basically meant for railway people, but nobody is barred. We will be happy if other people use it. Samadhi sir, good evening, sir. Good evening, excellent lecture. Thank you, sir. So nice of you. Your contact details, I will share it. Dr. Sun, do we consider any preventive measures for snake or rat pits in construction of MMM? No, because so far we have not faced much of the problems in this regard, to be very frank. So that's why we have not given anything specific for this. Are there any specific permissible settlement limits for those formation? This, as I told you, in our current specification up to 160 kmph, we have not put any this thing. And reason is simple. See, I will tell you. We have said that we will construct embankment only when my consolidation is completed, at least 70% of consolidation. if my ground is bad, I strengthen the ground, weak ground is taken care of, and then only we construct the embankment. And in embankment, the type of soil which we are permitting, most of the settlement will be primary elastic settlement, which takes place during its rolling itself. So there will not be much of the settlement. But let me tell you, in high speed, above 160, even 102 mm settlement can be fatal from the safety of the train. And from that point of view, when we go for high speed, permissible settlement values will also be specified. Presently, we don't have this. Okay, thank you, sir. Excellent lecture. Okay, I think there are no more questions. I will just, with your permission, Dr. Ramarao, can we take 2 minutes just to show our website and what is the source resource material available there? Can I?
Okay, sir. Okay,
show
sir.
it?
Okay.
Right. You can just type Irisen on Google search if you don't remember. This is our website, www.irisen.gov.in. There are some very beautiful things, I will tell you. Number one, all our railway codes and manuals are here. My screen is visible, Dr. Ramarao, sir?
Sir.
Yeah. So first is code and manual. All our updated up to last Monday codes and manual related with our bridges, anything. If you go in this, I will just show you. Everything is available here. It takes a little bit more time because resources are shared. Then next is Irisen publications. We publish our journal every quarterly and a lot of other things that is available. This is a beautiful thing. If somebody, in fact, recently just I am in charge of this. We have made a digital lab. If you go to this, all tests, we have got a very beautiful lab as comparable with any engineering college or maybe comparable with IITs, and we are going on adding equipments there. So there are geotechnical engineering, ballast and aggregate, cement, concrete. This is for railway, of course, ultrasonic. So if you go to geotechnical engineering, all these lab tests are there, like grain size analysis, wet and all. Any test, let us say I want to see direct shear test. If you go there, the test procedure is there. What is the apparatus used is there. The reference is there. On the same thing, I've written a book also for our people. Then how to prepare specimen, what is the test procedure, everything, how to do the calculations, how to prepare the report. And finally, there is a video on every test. This video either we have taken from YouTube or we have prepared ourselves. So you can see the whole test procedure on video. And in fact, visitors coming to our lab, we have made virtual lab. There are smart TV screens in front of machine. You can see there, you can conduct test yourself. No instructor is required. And you can download this procedure also here. Only thing is, video cannot be downloaded. So this is the next thing, digital lab. Anybody can make use of. Then we have made a lot of softwares for, of course, there are railway applications, but some of them, like I made a software recently, very simple in Excel, ground improvement like this, ground improvement version 4. There is a paper where it says how this software is made. It is an interactive software, not like black box software where it is an Excel sheet. You can keep on writing your project's data and you can learn the, this is how we teach our trainees. You can learn it and you at the same time, you can solve it also. In fact, I am making a software, it is almost ready for RE wall design. Internal stability one, it is under beta testing. That also will load here. So you can use these features also. Then this is the other teaching and presentation material. Every day we have got 8 courses. So every day 8 into 6, 48 hours lectures we give on various topics. Here, all our those presentations and teaching material, all our PPTs, everything, wealth of information. Anybody who have got patience can increase this. And below this, I'm going to put in next 1 week because now Pune is under lockdown for 10 days. I'm not able to. Our digital model room where various components of track, rail, sleeper, anything, their photo will be there, their videos will be there. And these facilities every month we are adding something, some animation or something. And another is this beautiful piece of this e-learning. I will just show you. In e-learning, our recorded like NPTEL, we are trying to develop NPTEL of railway equivalent to that. So track machine and bridge and works. Here you see in works, you will have, these are my lectures, soil classification, geotechnical investigation, slope stability analysis, file foundation. Today evening, I'm going to add in yard drainage. So a lot of information is available. It is free. We don't charge. Previously, only members were allowed. Now it is free for anybody. So kindly make use of this website. That's all. That is what I wanted to say in the end. And I will stop sharing screen. Yeah. Next one question is, what are the ground improvement methods in expansive clay for high speed? See, I will tell you, if your soil layer, bed soil layer is up to 3 meters, world over there is a practice, because why I did a project in Malaysia where soil is 10 times worse than this. And that was a project for 160 kmph on meter gauge. That's the highest speed in world on meter gauge today. And best type of ground improvement was done. So world over practice is up to 2 to 3 meter. If your soil is bad, then you do either full or partial replacement of that soil with a good granular non-cohesive soil. And if your depth is more than that, then you have to do deep penetration improvement, which can be most commonly used is your PVD. But what happens in some case, your soil is so bad that even after doing PVD, even after consolidation, pore water pressure gets dissipated, you don't get required strength, threshold strength. In case of railway embankment, we talk strength under dynamic load condition. And there we have to go for stone columns. And now I think here in your forum only or somewhere I have recently heard, nowadays there are geosynthetic encapsulated stone columns also, where lateral displacement is very high and where stone columns don't work so nicely. There is no Indian code, there is an EBGO German code. Yuskar has done a lot of design. On their website you can find a lot of material. So these are the method. Which type of soil is best? Every soil is best which you can get at the least cost, provided that it is not unsuitable. As I have told you, we have only defined unsuitable soil in very few soils, and there also, if it is inevitable, you have to do some measures. You have to take a consultancy from RDSO or some competent. Other soils, only thing happens is the bottom layer is weak, then top layer thickness is increases, blanket thickness increases. Ultimately, the pavement as a flexible layer, as a composite system, has to give me the required stiffness for my track bed. That is the track design philosophy. So that is our requirement. That's all. I think with that I have covered all the questions. So my email ID and this one thing is, of course, as I told you, on our website is also there, but still I will write here. It is Shekhawat, SHEKHAWAT, Shekhawat.Rajesh @iricen, IRICEN.gov.in. This, and my mobile number, you can, my phone mostly remains switched off or in silent mode, 74200411104. But you can send message to me, and if you send mail, I will revert back to you if there is anything which I can do. Shekhawat.Rajesh @iricen.gov.in. This is available on our website also, in case you forget, and this is my mobile number. Okay, if nothing else is there, I think we can call it a day. I will again like to thank Dr. Ramarao Garu for having given opportunity for interacting with such a good audience. Thank you very much.
Once again, I thank Mr. Rajesh Kumar Garu, giving brief lecture on design and construction of railway formation on behalf of Dr. M. Ramarao Garu. Ramarao sir is having some personal work, sir. Once again, I thank you.
Thank you. Thank you,
I
everyone.
will close the section.
Right. Thank you.